Linear functions. Y'all are going to notice my notes are off a little bit, so I'm going to have to be around the screen a little bit more. But your notes are printed correctly, so make sure you're paying attention to your notes. Okay? You talked with your partners a little bit about what you think lines are, what you think is relevant to a line. What do you think rate of change is?
Can I have a slope paper?
Slope. There's actually extras right here if you want to come grab one. Slope. Well, what else do you know about slope? It goes through. Oh, just kidding. Rise over run.
Did I miss you recording it?
Okay. What else?
No.
It can go through the origin occasionally. When we talk about direct variation, we'll get there next time. Okay? What else do you know about slope? You told me a formula a second ago.
Oh, y1, y2, y1
Over.
x2.
And guys, I want to explain something to you that I don't know was really explained to y'all last year. With this equation, if you mix up your y2 and y1, it's okay. You always have to make sure you keep your partners together. So if like y2 has to be on top of whatever x2 is. y1 has to be on top of whatever x1 is. But they can be switched where y1 comes first and y2 comes second. As long as you keep your partners lined up. Does that make sense to everybody? Okay. What's another way or another thing you know about slope? There's a letter that represents it. M. Okay, think about it. What do you ride, when you ride on the slopes, what are you on?
A motorcycle.
What did you say?
When you go down the slopes, what are you on?
Motorboat.
Good Lord, have none of y'all been skiing? Ever. Nobody's been skiing.
Yeah,
You're on snow, but you're on top of a mountain. M for mountain. Slope.
Motorcycle.
Okay. Excuse me?
We talked about y equals mx plus b.
Y equals mx plus b. We're going to get there. But yes, that is a linear function. And we're going to talk about that here in a second. Okay? So, keep that in mind. Don't let it go out. Now, when we're talking about slope, the reason that they put an M for slope is because when you're skiing on the slopes, you're on a mountain, so they put an M there. I don't know why, but math people are weird. Okay? Now, what do you think x-intercept stands for?
Oh, where the line crosses the x-axis.
Where the line crosses the x-axis. Where the line crosses the x-axis. Okay? Now, when a line crosses just the x-axis, their ordered pair is going to have a number for your x. But what would your y be on the x-axis?
0.
0. Okay? So here's the deal. If you're ever given an equation and it says find the x-intercept, you're going to plug in a 0 for y, then solve. Because if it wants you to find the x-intercept, that means you need to find the x. Would you agree?
Mm-hmm.
So we're going to plug in 0 where our y is, because that's where it crosses, and then we'll find the answer for x. Okay? We'll talk about that here in a second a little bit on that homework. Now, zeros. There are some different names for zeros, and they are as the following. You might see them written as solutions. You might see them written as x-intercepts. And the other name you might see them as are roots. And that's kind of a weird one, right? Everything else kind of seems mathy. Solution, x-intercepts, and then all of a sudden it throws science in here, roots. Okay? Well, what do roots go in? The ground. So do me a favor. If you were to draw a graph, which one would be the ground? My x-axis. Here's your ground. So if I'm looking for my zeros, and I know that they're called solutions and they're also called the x-intercepts. X-intercept is where it crosses the what? X-axis. So another name for an x-intercept is roots, because that's where it takes root on the x-axis. Everybody understand that? I know it's kind of silly, but that kind of makes a more visual image of why it's called roots. Okay? So when it crosses the x-axis, that's called an x-intercept, a solution, a root, or a zero. Now guess what? I'm not trying to trick you. What do you think a y-intercept is?
Where the line comes to that line.
Yes, where the line crosses the y-axis. Okay? What's that going to look like as an ordered pair? 0, comma, number. Because you're going to have a number where the y is and nothing else on it. Now, instead of plugging in 0 for y, what do you think you're going to do? Plug in 0 for x, then solve. Okay? So if they ask you to find the y-intercept, you're going to put a 0 wherever your x is and solve the equation. If they ask you to find the x-intercept, you're going to put a 0 wherever your y is and solve the equation. It's always the opposite. You put a 0 in for the opposite of what they're asking for. Everybody understand that? Are we okay with that? It's a little confusing, but how do you feel?
Amazing.
Okay? Let's go talk about tables and patterns. We need to be able to determine if something's linear or nonlinear based on their table or the pattern they follow. Okay? So this is what your notes look like, except for the name and period up here. Where name and period are, that says what?
Oh,
Linear.
Table and patterns.
Tables and patterns.
And linear and non-linear.
And then it says linear,
Not
nonlinear. Or not. Okay? So that's what y'all's looks like. Mine kind of printed weird. I apologize. So, here's what we've got to do and got to understand. If something is a linear table or a linear pattern, it's constant. Okay? It's got a constant rate of change. What was another name for a rate of change?
slope.
Yes. So, if it is a linear situation, it's got a constant rate of change. And the other word I want you to write there is slope.
This is for constant. I mean linear.
This is just for tables and patterns. Figuring out if it's linear or not. If it's linear, it's going to be constant. Okay? So let's go figure out, based on our tables and pattern up there, how we can determine if something's linear or non-linear. So what I'm going to do is I'm going to look at the numbers. So my x's are what? What are all numbers?
0, 0, 6, 12.
Perfect. And then my y's are? Okay, so I'm going to try to figure out, is there a pattern between these numbers? So how did I get from 0 to 2? Times 2? Plus 2. Perfect. What about 2 to 6? Plus 4. What about 6 to 12? Plus 6. Okay. What about from 8 to 13?
5.
What about 13 to 23?
2.
And then 23 to 38?
15.
Perfect. Now, you told me that this has to be a constant rate of change or a constant slope. How do you find slope again?
Y2 minus Y1.
Okay, so here's a shortcut to writing y2 minus y1 over x2 minus x1. You're going to say delta y over delta x. What that means is the change in y over the change in x. So if you'll look here for me, what's the first change in y you see? 5. Who's its change in x?
2.
5 over 2. What's the next change in y? 10 over 4. And then 15 over 6. But again, we said these have to be constant. Do they look constant right now?
Mm-mm.
But this is on the linear side. So it has to be constant. But what should I do to figure out if it's constant or not? You did this on your counting for slow paper. You had to plug it in your calculator, and you always have to
Divide and then
Simplify.
simplify. So in your calculator, type in 5 divided by 2. What do you get?
2.5.
It's a decimal, so what do you have to change it to?
math,
Math inner. What do you get?
5.
5 over 2. Perfect. 10 divided by 4. What do you get? As a simplified. Simplify it.
5 over 2.
Perfect. What do you get as 15 over 6? 5 over.
2.
So now, looking at all these slopes, 5 over 2, 5 over 2, 5 over 2. Is it constant?
Yes.
Okay. Did it follow a pattern?
Yes.
Yes. What did you notice about this pattern, guys? What was I doing?
Adding.
I was adding. So I want you to add this up here into your notes. Tables and patterns, you must be adding or subtracting. Anything else will not be linear. So if it talks about multiplying from one spot to the other, it's not linear. Okay? So this was constant because 5 halves was the same slope for every number. Now look at this pattern for me. Right here. 2, 8, 14, 20, 26. Can you find a pattern? So from here to here was plus 6. Then what? Plus 6. Then what? Then what? So what's my pattern?
Plus 6.
Plus 6. Is it constant?
Yeah.
Was I adding or subtracting?
Adding.
Adding. So this is considered
A linear.
linear function. Good job. Now let's look at why this is nonlinear. How did I get from negative 10 to 5? Or negative 5?
Plus 5.
Plus 5, right? We went from a big negative to a smaller negative, so we added. How did I get from negative 5 to 0?
Plus 5.
What about 0 to 5?
Plus 5.
Okay. How did I get from 10 to 4?
Minus 6.
What about 4 to 2?
Minus 2.
And 2 to 0?
Minus 2.
Now remember, I can write delta what?
Y.
Over
Delta
delta x. So that just means change in y over change in x. What was my first change in y?
Negative 6.
Negative 6 over 5. What was my second change in y?
Negative 2 over 5.
Good. And my third change in y?
Negative 2 over 5.
Do something for me. It has to be constant in order for it to be linear. Is negative 6 over 5 going to be the same as negative 2 over 5?
No.
So obviously it's not constant, therefore it's non-linear. Are we okay with this?
Yes.
It was adding or subtracting, but it wasn't constant. So let's look at this pattern.
2.
How do you get from 2 to 4?
Plus 6.
What about 4 to 8?
Plus 4.
8 to 16?
Plus
16 to 32?
Plus 16.
Okay, is that constant?
No.
So when I was adding or subtracting, it wasn't constant. But I want you to see if you can find a different pattern. What's another way to get from 2 to 4?
Times 2.
Times 2. What about 4 to 8?
Times
8 to 16?
2. Times 2.
And 16 to 32?
Times 2.
Okay, this is constant, but I am now multiplying. So it's no longer linear. It's actually going to become quadratic. We'll talk about that later. Okay? So there's the difference. Does everybody see the difference between those?
Yes.
Now let's go to the top right corner. This is the easy one. Graphing. And mine's all janky. Okay? So graphing. How are you going to know if a graph is linear or not linear?
If it makes a straight line.
Okay, perfect. So when we're looking at graphing, our graph must be a
Straight line.
straight line. Because linear line. Okay? Now, there are different options for a straight line. What are they?
What?
Tell me how to draw a straight line.
Up
Okay, so up and down. Here we go. There's an up and down. What is this called? Vertical. So one of my straight lines could be vertical. What's another option? Horizontal. Any more straight lines?
Diagonal.
Diagonal, which way?
Both.
Okay, so I could have one that goes up. Or one that goes down. Okay, and I'm going to end every line in arrows because lines keep going. Okay, and domain and ranges of linear functions are super easy because there's arrows on the left and right side, top and bottom. So your domain and range for linear functions are usually what? All real numbers. Keeps going. Okay? So those are my linear functions. Help me draw some nonlinear.
Curved line.
A curved line. So like,
Well,
what was this called?
Oh, it's that.
Yes, this was called an exponential. It bottoms out, but it is also curvy. It's got that curve to it. So it's no longer a linear function. What else? What's another one?
Rainbow.
A rainbow, which is called a quadratic. Have you seen any other examples?
Yeah. No. Upside down quadratic.
Which would be a normal quadratic, a U. Okay. What about this? Have y'all seen this ever?
Oh, yeah.
Yeah.
It's a circle. So is a circle going to be a linear function?
No.
No, because it's a circle. Okay? Most of your shapes are not going to be linear because they're going to have more than one line involved with them, or they're going to be curved at some point. Okay? So for example, some people were like, well, triangle, but no, a triangle has how many sides? 3. So is that one line? No, that's 3 linear functions put together. Does everybody understand that? Okay? So that was pretty easy. Now let's do the last part. Some of these you're going to remember how to do from last year. What is, Sydney, slope-intercept form? Y equals mx plus b. Do y'all know why it's called slope-intercept form? I'm going to blow your mind real fast because math people are geniuses. They're the most creative humans in the whole world. Ready? Slope. It gives you the slope. And intercept, because it gives you the intercept. What's your B? Which intercept? It's your y-intercept. Look at how creative we are. The reason it's called slope-intercept form is because they give you the slope and the intercept. Pretty simple? Okay? So, point-slope form. I don't know if you've ever seen this before, so I'm going to give this to you. Y minus y1 equals m parentheses x minus x1. You might not have ever seen it before, but because math people are so creative and like the most awesome humans ever, what do you think they provide you with? They definitely give you the slope. Which letter is it? Your M. What else do you think they're going to give you?
Your Y.
Your point.
A point, which is your X and your Y. So guess what your point is? It's these weird ones that have ones next to it. So your math people give you the point and the slope, and that's when you're going to use point-slope form. Now last one. You have seen this before. Okay? And some of you actually wrote it down that day I asked y'all to write equations you'd seen before. Capital A, little x, plus capital B, little y, equals capital C.
Oh, a squared plus b squared equals c squared.
That's close. It leads you into Pythagorean theorem. Okay, so this is kind of similar to something you've seen last year. This is called standard form, and I have no clue why it's called standard form. It's just standard. Okay? So standard form is when they give you the x and the y on the exact same side. Okay? So the x and the y are on same side. Are we okay with that? Notice they didn't call it slope standard form because they didn't give you the slope here. They just gave you the x and the y on the same side. That's why it's called standard. Sound good? Okay. So I want you to